Hi guys, welcome back to Outsmartable Educational Videos. Today we're going to talk about radical expressions. What is a radical expression exactly? Well, you have a mathematical expression contained within a radical symbol. This little symbol here is called a radical. The value of the expression under that radical symbol is called the radicand, and the number to the upper left-hand corner is called the index. If this index is omitted, it defaults to a value of 2. Otherwise, you have to specify the index if it's not 2. Let's talk about perfect squares, perfect cubes, perfect fourth roots, things like that. Here's a set of 6 integers. The square of those integers is in the next row. 3 squared is 9, 6 squared is 36. So we say these numbers that are the result of squaring an integer are perfect squares. When we cube these numbers, in other words, raise them to the third power, we get these values. So we call these values perfect cubes. 125 is equal to 5 times 5 times 5, or 5 cubed. So we say 125 is a perfect cube, and so on. Here you have those integers raised to the fourth power. 3 multiplied times it, so 4 times is equal to 81, or 3 to the fourth power equals 81. So these are perfect numbers to the fourth power. We also say 81 is has a perfect fourth root. Its fourth root is 3. 8 has a cube root, that would be 2. 216 has a cube root, which is 6. 1296's fourth root is 6. Okay, with that in mind, let's work some problems here. The square root of 16 is equal to 4, because 16 is a perfect square. 72, this is, remember, defaults to an index of 2. Does it have a perfect, it is not a perfect square, is it? We don't see it in this row. It's not equal to 7 times 7, or 8 times 8, or 9 times 9. But whenever we have a situation like this, what we do is we look for a factor of the radicand, which is a perfect square. We need a perfect square, and namely 36 in this case is a perfect square, and its square root is 6. So this is equal to, we can take the square root of 36, we factored 72, so that the 36 is a perfect square. That leaves the 2 inside the radical symbol. So we took the square root of 36 and got 6. I left the square root of 2 in there. How about 71? Can you think of a factor of 71 that's a perfect square? No, I can't either. So that's in its simplest form. How about the fourth root of 512? Do you see 512 anywhere in this fourth row? Now do you see a factor of 512 that does have a perfect fourth root? If you said 256, you're right. So we rewrite this as 256 times 2. And 256, its fourth root is 4. And we have to leave that 2 inside the radical symbol. How about this one? Typically, the idea here is to simplify, and to simplify in this case means get rid of the radical symbol in the denominator. How do you do that? Well, the easiest way to do it is to multiply the fraction times 1, where 1 is equal to this thing divided by that same thing, 1. Doesn't change the value of the fraction, but what it does do is in the denominator it gets rid of the radical symbol. That's considered to be in simplest form. How about the cube root of 128? Do you see 128 anywhere in this row? Doesn't have a perfect cube root. Do you see something that is a factor of 128 that is in this perfect cube row? 64 is correct. So if we rewrite this as the cube root of 2 times 64 times x cubed times y cubed, and then we can take the 64 out, its cube root is 4. We can take the cube root of x out and the cube root of x cubed out. That leaves just the cube root of 2 inside the radical symbol. How about this next one? Cube root of 125 is 5, right? Now, let's rewrite this. It's like 5 cubed times x cubed times x. So we can take out the 5, we can take out the cube root of x cubed, but that leaves inside the radical symbol the cube root of x. That little 3 there is in the upper left-hand corner of the radical symbol. How about this one? Again, we want to get rid of the radical in the denominator, don't we? So let's multiply top and bottom. What would you multiply this by to get rid of the radical in the denominator? Do you see that that would make this the cube root of x cubed? So we've got to do the same thing in the numerator, don't we? That gives us, in the denominator, the cube root of x cubed, which is namely x, and in the numerator we have the cube root of 3x to the 6th. Now, x to the 6th has a cube root. It is equal to x squared. So we're going to take that x squared out. Leaves the cube root of 3. X squared times the cube root of 3. And we can cancel x squared with x. So we get an answer here of x times the cube root of 3. How about this one? This one's a little nasty, isn't it? It has a sum. You want to multiply this times the conjugate. What is the conjugate of this denominator? It's, instead of 8 plus square root of 7, it's 8 minus square root of 7. Now we need to do the same thing in the numerator, don't we, to keep the value of the fraction the same. If you multiply a conjugate, what you get is, using FOIL, what you will get is the square of the first term minus the square of the second term. Square of 8 is 64. Try it with FOIL. You get 64 plus minus cancels minus 7. But in the numerator, what are you going to have there? You're going to have 8 minus the square root of 7, that quantity times 15x. Okay, now 64 minus 7 is 57, right? How about this one? You want to get rid of the denominator that has a radical in it, so multiply times xy squared. See, in the denominator we get xy squared, and in the numerator we get the square root of 3x to the 4th, y to the 6th, where that equals, let's see, you're going to have x squared, y, well, I better come down here, running out of room, equals x squared, y to the 3, square root of 3 over xy squared, cancel the x squared with the x, cancel the y cubed with the y squared, and that's your answer. How about this next one? Nothing we can do to simplify that, so that's in simplest form. What would you do to this one? Multiply times the conjugate again, right? 5 plus the square root of 2x, 5 plus the square root of 2x. Probably want to put this all in parentheses. In the numerator you get 5 plus square root of 2x quantity squared, and in the denominator what are you going to have? 25, that's square of the first term, minus 2x. Okay, just a little work out there with radical expressions. Hope everything's going well for you. Look forward to seeing you in the next video. Have a great day.